This is a video on the Fundamental Elements assignment number 1. In problem number 1, we're given this expression and we have to simplify it, so we're going to use the distributive law. So we get 2 times 7, which is 14, minus 12x plus 4x minus 20. And then we're going to combine like terms. So we've got a minus 12x and a plus 4x, which adds up to minus 8x. And we have a 14 and a minus 20, which is minus 6. And we see that that has the form ax plus b, as advertised here. So a is the number in front of x, so that's minus 8. And b is the constant that's added here, which is minus 6. In question 2, we have to add these two fractions, and they have the same denominator, so we just have to add the numerators. So we're going to get y squared plus 25 minus 10y over y squared minus 25. And I'll rearrange the terms in the numerator. And then we notice that both the numerator and the denominator factor. So the numerator factors into y minus 5 squared, and the denominator factors into y minus 5 times y plus 5. And we see there's a common factor of y minus 5 in both the numerator and the denominator, so we can cancel that. And so we get left a y minus 5 in the numerator and a y plus 5 in the denominator. So that would be the simplified answer. Y minus 5 divided by y plus 5. So these are true-false. So we can see that the first one is not true because we can't cancel the x from the numerator and the denominator because there's no x with the y. You can see that, for example, if we plug in some numbers, if x is 2 and y is 3, then the left-hand side would be 2 over 2 plus 3, which is 2/5. And the right-hand side would be 1 over 1 plus 3, which is 1/4. And so these clearly are not the same, so that's false. The next one, if we look at the left-hand side, x plus 16x over y plus 16y, well, we can plug, we can plug out an x and get 1 plus 16, and similarly a y and get 1 plus 16 in the denominator. So the numerator is just 17x and the denominator is 17y, and we can cancel the 17, so we get x over y, and so this is true. And similarly c is true because we can distribute that denominator. 16 plus a over 16 is the same as 16 over 16 plus a over 16, or 1 plus a over 16. So this is true. And then the last one is not true. We cannot distribute the denominator. So, for example, if x is 10, the left-hand side would be 16 over 96, which is 1/6, I believe. Yeah. And then the right-hand side would be 16 over 86 plus 16 over 10. And well, you can see the right-hand side is bigger than 1, so it can't possibly be equal to 1/6. So this is going to be false. On this one, we want to have a common denominator, right? So 5 over a plus 3 over b. Our common denominator would be a times b. So in essence, we're multiplying that first one by b over b and the second one by a over a. And so we get 5b over ab plus 3a over ab. And now they have the same denominator, so we can add the numerators, 5b plus 3a over ab. So that's our fraction, 5b plus 3a over ab. This is question 5, and for part A, we can write 3 over 30 as 1 over 10. And 6/9 reduces to 2/3. And, well, we can cancel a 2. So we end up with 1 over 3 times 5, or 15. So 1 over 15. Part B, the minuses are going to cancel each other, so we just have 1 over 3 times 36 over 13. And again, we can cancel a 3, so that's like that. And so we're just going to be left with 12 over 13. And then this part C, we have 3 pi over 2. And we're dividing by 2 pi over 3, which is the same as multiplying by the reciprocal, so 3 over 2 pi. And then we can cancel the pi's. And so in the numerator, we just have 3 times 3, which is 9. In the denominator, we have 2 times 2, which is 4. So our answer is 9/4. And then for part D, let's see, we can write x cubed y squared over w to the 5th, and then we're going to multiply by the reciprocal of that denominator, so w to the 4th over x cubed y cubed minus 5x cubed. So we can see that we can cancel w to the 4th. And then, let's see, we have x cubed y squared upstairs. We have a w, and then I can see that there's an x cubed that I can factor out, and we have y cubed minus 5, and so now x cubed cancels. So we are left with a y squared in the numerator and a w times y cubed minus 5 in the denominator. So that's the answer right there. For question 6, part A, we need a common denominator, which is going to be 14. So 1/2 is 7 over 14. And 4/7 is 8 over 14. And then minus 11 over 14. So now they all have the same denominator, so we can combine the numerators. So 7 plus 8 minus 11 over 14, which would be 4 over 14. and that reduces to 2 over 7. And then for part B, well, the numerator is 3 sixes minus 2/3, which we'll write as 4 sixes to have the same denominator. And let's reduce 2/4 to 1/2 minus 2/5. So the numerator is 3 minus 4 over 6. And the denominator, we can have a common denominator of 10. So we'll write 1/2 as 5 over 10 and 2/5 as 4 over 10. So 3 minus 4, that's minus 1 over 6. And then 5 minus 4 is 1 over 10. So this is just minus 1/6 divided by 1/10, which is the same as multiplying by 10. So that's minus 10 over 6, which is minus 5/3. And so that's the answer to part B. So the first one, we have to set over a common denominator of x plus 1. So we're going to write x plus 1 squared over x plus 1 plus 1. So that's going to be x squared plus 2x plus 1, and then plus another 1, so plus 2 over x plus 1. So the numerator is x squared plus 2x plus 2, and the denominator is x plus 1. And then this one, we also need a common denominator. This is going to be x minus 1 times x plus 1. And then we're going to have x plus 1 minus x minus 1. So we're going to have x plus 1 minus x plus 1 over x squared minus 1. The x's cancel. And so this is just 2 over x squared minus 1. So the numerator is 2, and the denominator is x squared minus 1. All right, for this, for question 8, part A, I'm going to multiply top and bottom by a squared b squared. And on the numerator, the first one, 1a cancels, and so I have b cubed a, or ab cubed. And in the second one, 1b cancels, so I have a cubed b. And then in the denominator, on the first one, the a squares cancel, and I just have a b squared. And then for the second thing, the b squares cancel, and I just have an a squared. So I can factor out an a and a b, and get left a b squared minus an a squared. And the b squared minus a squares cancel. And so I'm just left with ab, which I can think of as ab over 1. So my numerator will be ab, and my denominator will be 1. For part B, I will multiply top and bottom by b minus 2. So that'll give me an a times a b minus 2 plus 2a, because the b minus 2 cancels. And in the denominator, I have an a times a b minus 2 minus 2a. So that'll be ab minus 2a plus 2a, and then ab minus 2a minus 2a. The 2a's in the numerator cancel each other, and in the denominator they don't, so I have ab over ab minus 4a. And then I notice that there's an a in each term, so I can factor an a out and have a times b minus 4, and the a's cancel, and so I'll just have b over b minus 4. So my numerator is b, and my denominator is b minus 4. Finally, for part C, I have a minus b over a over b plus b over a. So first thing I'll do is deal with the fraction, and I'll multiply top and bottom by ab. So that'll give me ab squared, and then in the denominator, the first term, the b's cancel, and I just get a squared. And for the second term, the a's cancel, and I just have b squared. And then I want to put everything over a common denominator. So I have to multiply a by a squared plus b squared, and then minus ab squared. So that's a cubed plus ab squared minus ab squared over a squared plus b squared. So the ab squares cancel, and I just have a cubed over a squared plus b squared. So that's a cubed, and for the numerator, and a squared plus b squared for the denominator. Okay, so in this question, we're just simplifying some numbers with fractional exponents. So we know that 9 to the 3/2 is 9 to the 1/2 cubed. So that's the square root of 9 cubed, so that's 27. The second one is 29 to the 3/2, so that also is 29 to the 1/2, and then cubed. Square root of 25 is 5, so that's 5 cubed, and that's 125. 100 to the 7/2 is 100 to the 1/2, and then to the 7th. So that's a square root of 100, which is 10 to the 7th. So that's a 1 with 7 zeros. And then the last one is the cube root of minus 64, so that's minus 4. In this one we have some negative exponents, so this is 1 over 9 squared, so 1 over 81. This is 1 over 25 to the 3/2, but we've computed that in the last question, so that's 125. So 1 over 125. This is 1 over the cube root of 1/27. The cube root of 1/27 is 1/3, so 1 over that is 3. And then this is 1 over 7 to the minus 2 is the same as 7 to the plus 2, so that's 49. Okay, we have a lot of square roots in this problem, so we can use we know that the square root can be distributed across a product. So we can write this as the square root of w to the 6th times the square root of x to the 4th, and that's going to be w cubed times x squared. And this is the cube root of 27 times the cube root of w to the 12th. So the cube root of 27 is 3, and the cube root of w to the 12th, well, that's w to the 12th to the 1/3 power, and we multiply the exponents. That's 12 over 3 is 4, so 3w to the fourth. This is the square root of 49 times the square root of x to the 8th times the square root of y squared. So that's going to be 7x to the fourth times y. And for this one, we want to put them together. So we're going to have 32 times w to the ninth times y to the sixth times 2 times y to the eighth times w to the fifth, square root of all that. Well, 32 times 2 is 64, so that we can combine these two. And then for the w terms, we can add the exponents. So w to the ninth times w to the fifth is w to the 9 plus 5, which is 14. So that's these two. And then y to the sixth times y to the eighth. Again, we add the exponents, and that's y to the 14th. So this is the square root of 64, square root of w to the 14th, square root of y to the 14th, and that's going to give us 8 times w to the 7th times y to the 7th. Okay, now we want to simplify this expression, so we can distribute the exponents. So we're going to have 9 to the 3 halves times s to the minus 6 to the 3 halves times t squared to the minus 3 halves, to the plus 3 halves, sorry. 3 halves. And then in the denominator we have 27 to the 2/3, s to the 6 to the 2/3, t to the minus 3 to the 2/3. So 9 to the 3 halves, well, that's the square root of 9, which is 3 cubed, which is 27. And then s, we multiply the exponents, so minus 6 times 3 halves is minus 9. And we multiply the exponents for t, so 2 times 3 halves is 3. And then in the denominator, 27 to the 2/3 means the cube root of 27, which is 3 squared, which is 9. Then s to the 6 times 2/3, which is 4. And t to the minus 3 times 2/3, which is minus 2. Okay, we can cancel a 9, right? So we get 3. Then we have an s to the 4th in the denominator and a t cubed in the numerator. We have an s to the minus 9 in the numerator, which we can move down to the denominator by making it a plus 9. And similarly, the t to the minus 2 can move upstairs as a t to the plus 2. So that leaves us with 3t to the 5th, adding exponents, over s to the 13th. And now it has the right form. It's of the form n t to the a, s to the b, where n is a 3. A, the exponent of t, is 5, and b, the exponent of s, is 13. Okay, now here on this problem, we're going to rationalize the numerator. So remember how we do this. We multiply by the conjugate, right? So we're going to multiply by the square root of 3t plus 4 plus 2 over the square root of 3t plus 4 plus 2. And then in the numerator, we end up with 3t plus 4 minus 2 squared, so minus 4. And in the denominator, we just have the product of the two denominators. So the 4's cancel, and we just have 3t left in the numerator. And the denominator is the same. Okay. And then now we can cancel a t. So finally we have a 3 in the numerator and the square root of 3t plus 4 plus 2. In the denominator, we're supposed to write it as a over b, so a would be the numerator 3, and b would be the square root of 3t plus 4 plus 2. This one is similar to the last one, right? So we're again going to rationalize the numerator by multiplying by the conjugate. So square root of x plus 2 plus 3 over the square root of x plus 2 plus 3. So in the numerator, we're going to get x plus 2 minus 3 squared, so minus 9. In the denominator, we just have the product of the two denominators. So that's that. Okay. And then the numerator simplifies to x plus 2 minus 9, x minus 7. So that is going to cancel with the x minus 7 in the denominator, right? So that would just have left 1 over the square root of x plus 2 plus 3. So 1 for a, and square root of x plus 2 plus 3. Right, and remember, when you put these into web work for the square root, you're just going to write square root like that. All right, in this one we have to factor in order to simplify, so the numerator factors into, let's see, x plus 5 times x minus 2. And we have an x minus 2 in the denominator, so we can cancel. And so this just simplifies to x plus 5. More factoring. So the numerator here factors into x minus 7 times x plus 2. And the denominator factors into x minus 2 times x plus 2. So the x plus 2's cancel, and we have x minus 7 over x minus 2. We want to simplify this square root. So we remember that 27 is 3 times 9. So we can bring the 9 out of the square root by taking its square root, which is 3, right? So we get 3. And the y to the 8th we can bring outside because its square root is y to the 4th. And then the only thing that's left inside the square root is the 3. And we're supposed to write it as a square root of c, right here. So a is the whatever's outside the square root, so that's 3y to the 4th. And c is whatever's inside the square root, so that's 3. More square roots, so we're given this. So again, any perfect squares inside we bring outside. So the 16, square root of 16 is 4, so we can bring it outside as a 4 and leave the xy inside. Square root of 9 is 3, square root of xy. And square root of 64 is 8. And so we've got 2 times 4, which is 8, minus 3, plus 3 times 8 is 24, all times the square root of xy, because that can be factored out. And 8 minus 3 is 5, plus 24 is 29, so this is 29 square root of xy. And again, we're supposed to write it in the form a square root of c. So a is going to be whatever's outside the square root, which is 29, and c is what's inside the square root, which is xy. Okay, so here we have x minus 3 times x plus 4 squared minus x minus 3 squared times x plus 4, and we want to factor it. And we see that x minus 3 is a common factor, and x plus 4 is a common factor. And what do we have left? We have one factor of x plus 4 left from the first term, and one factor of x minus 3 left in the second term. So this is going to be x minus 3 times x plus 4 times x plus 4 minus x plus 3, because we have to distribute the minus sign. The x's cancel, so we're going to have 4 plus 3 are 7 times x minus 3 times x plus 4, which has the form that we are looking for, ax plus b times x plus c, right? Where a now has to be 7, b would have to be minus 3, and c would be 4. And we just need to make sure that b is less than c, which it is. So a is 7, b is minus 3, and c is 4. All right, for this last question, we again want to factor, and we notice that there's a common factor of 2 that we can bring out of this first term. So we'll bring that out, and we have a 3x minus 4, and then 5 times 3x minus 4. And so we can factor out 3x minus 4 from both now, and we'll get left 2x minus 5. So that's our answer here, 3x minus 4 times 2x minus 5. And then we want to find the zeros of y equals 3x minus 4 times 2x minus 5, so that means we want to find the solutions of 3x minus 4 times 2x minus 5 equals 0. But the only way a product can be 0 is if one of the factors is 0. So either that's 0 or 2x minus 5 is 0. So in the first case, we would get 3x equals 4 or x equals 4/3. And in the second case, we get 2x equals 5 or x equals 5/2. So our solutions would be 4/3 and 5/2.